Have you ever pondered the inner workings of clustering algorithms, or how dimensionality reduction techniques simplify complex data? Today, we dive deep into these two fascinating concepts that have revolutionized the way we handle and interpret data. Imagine you're in a field filled with different types of flowers. You want to group them based on similar characteristics, say color or petal size. This is the essence of clustering, the process of identifying and grouping similar items in a dataset. In the realm of machine learning, this process is often automated using clustering algorithms. There are numerous clustering algorithms, but we'll focus on two popular ones: k-means and hierarchical. K-means algorithm is widely used in various fields such as image segmentation, customer segmentation, and anomaly detection. Let's take a closer look at how it works. First, the algorithm randomly selects k initial cluster centroids. These centroids act as the center points for each cluster. Next, the algorithm iteratively assigns each data point to the cluster with the nearest centroid. This is done by calculating the Euclidean distance between the data point and each centroid. After all the data points have been assigned to clusters, the algorithm recalculates the mean value for each cluster. This new mean becomes the updated centroid for that cluster. The algorithm repeats the previous two steps until convergence is reached. Convergence occurs when the centroids no longer change significantly, or when a maximum number of iterations is reached. Once the algorithm converges, the final result is a set of k clusters, where each cluster contains data points that are similar to each other. It's important to note that the initial selection of centroids can affect the final result. Therefore, it's common to run the algorithm multiple times with different initial centroids and choose the best result based on a predefined evaluation metric. In conclusion, k-means is a powerful algorithm for data clustering. It can help uncover patterns and similarities in large datasets, making it a valuable tool in various applications. On the other hand, hierarchical clustering is like a meticulous botanist who groups flowers based on a hierarchy of characteristics. This algorithm creates a tree of clusters, where each data point starts as a single cluster and pairs up with the closest one until there's only one cluster left. Thus, it provides a hierarchy of clusters, hence the name. But what if the data is highly complex with numerous variables? This is where dimensionality reduction comes in. Dimensionality reduction is like a skilled artist who can capture the essence of a detailed scene in a few strokes. It simplifies complex data by reducing the number of random variables under consideration, using techniques like principal component analysis or PCA. PCA is like a photographer who finds the best angle to capture the most important features of a scene. It identifies the directions, or principal components, where the data varies the most, and projects the data onto these new axes, thereby reducing its dimensionality. In summary, clustering algorithms like k-means and hierarchical help group similar data points. On the other hand, dimensionality reduction techniques such as PCA simplify complex data by reducing the number of variables under consideration. So, the next time you see a field of flowers or a complex dataset, remember the principles of clustering and dimensionality reduction. They might just help you see the world and the data in a whole new way.